Okay, guys, so today we're going to talk about side, and what that means based on two triangles. And I apologize for my measurements and shape figures, but I'm going to draw to the best of my abilities. Let's say I have this triangle ABC, okay? And then I have this triangle XYZ. Okay. What I'm looking for is these little markers, and these indicators, markers indicate that these two things are congruent. And on these two triangles, we make this statement, right? So if I have this marker, it's a one dash, and this is a one dash. This is an indicator that side AB is congruent to side XY. Okay, so that's a statement right there, and that's what it means when two sides are congruent, and those are corresponding side lengths. So then we go to the next set, right? We talk about the next set. Now the next set's going to have two marks, right? This is to indicate that BC is not the same thing as AB. They're two different pieces, okay? So what we're going to show here is that BC is actually congruent to YZ. Okay, so we can make this statement: BC is congruent to YZ. Now, if I was using what we call the side postulate, this means that all sides of one triangle are congruent to all sides of another triangle, the corresponding parts at least. What I have here is a side and a side. What I'm missing is the third side that's congruent. So if I was looking for that third piece for us to have side in this triangles to prove that these two triangles were congruent, I would need something like this. I would have to have a statement that CA is congruent to ZX. All right, this would be my missing piece, my third side. Okay, and then that third side obviously would have three dash marks. Okay, 1, 2, 3, to indicate that it's different from the other two sides of the triangle. And this triangle would have 1, 2, 3, based on this statement. And this statement shows me side, which means that these two triangles are in fact congruent. So based on that, I can say that triangle ABC is congruent to triangle XYZ. And this is how you use side. And if you're missing that piece, that's what it's looking for. Okay, I'm gonna do one more piece, and I'm gonna draw kind of like a diamond to show side one more time. Okay, because there's a special property that we use a lot that may not be there. We want to make sure that we understand what's going on here. So what I'm gonna do is I'm gonna draw this little line segment from here to here. Okay, so that I can basically cut this two triangles into two equal pieces. Notice that those two triangles have that same side, right? So I'm going to go ahead and call this triangle, let's say, I don't know, I use ABC a lot. So I'm going to call it triangle ABC and triangle DBC, right? So in this situation, I'm going to go ahead and I'm going to say that I'm going to give you that AB is congruent to DB. Okay, I'm going to give that to you. So that means I need to make my little markers. AB is congruent to DB. Okay, so the one congruency marker dash. Okay, my next statement is I'm going to give you is that AC is congruent to DC. Okay, so I make my little two markers here. AC is congruent to DC. Now, what I have so far in this situation is side. In order to prove that triangle ABC is congruent to triangle DBC, I'll need my third side. And I can get that third side by using what we call the reflexive property. Okay, this third side, I'm going to use the reflexive property. And that means when I use this reflexive property, I'm going to say that BC is congruent to BC. That's that third missing piece so that I can have side. And with this situation, because I have side, I can now say that triangle ABC is congruent to triangle DBC. And that is how you do side, side, side. Okay.